I'll hit record on this part. So, you were given the Precipitation Lab sheet. Everyone should have had this sheet. That was here. If you are not here, it's imperative that you go get one of these sheets. It's imperative that you find somebody who was here to record the data of their table. You need their table to answer any of the questions that this is off of. Because this lab alone is worth 24 points. The quiz you're about to walk into is worth 35 points. You'll get several points for having a complete data table. The majority of your points are going to come from the analysis and conclusion section of your paper. Now, it does specify on another piece of paper, on a separate piece of paper, you're going to write and balance 10 pairs of solutions that produce a precipitate. Remember, those are the solutions that produce that solid insoluble powder in your observation well. Like when we mix copper 2 sulfate and barium nitrate, we saw a white powder, a whitish powder, right? Some people may record it as whitish blue, some may record it as bluish powder, but regardless of fact, we had some powder in that container, right? On a piece of paper, you're going to walk through, because all of these are double replacement equations. And I want you to see the skeleton of a double replacement equation. AB plus CD will yield or react to form BC plus AD. This is big. What you're going to do on the, well, first, before I get into that, this only works if we have a bunch of ionic compounds here. If things are ionic, that means I have a cation and an anion. If my first compound is A and B, which is the cation, the positive charge, A or B? A. Remember, it's an ionic compound. The cation is always written first. So the positive is always written first. The negative is written second. So if A is positive and B is negative, what's C going to be? Positive. It's a cation. What's D going to be? Negative. So in a double replacement reaction, A is going to go with D. B is going to go with C. I will never see an A and C interact with each other because they are positively charged. They'll repel from one another. Same reason why we'll never see a B and a D interact with each other, because they are negatively charged. They will repel from each other. All we're doing is we're swapping our dancing partners here. And the best part about it is that my table gives me all the reactants. So let's take a look at what I have to do. Number one, I have to predict the names of the products of each reaction. I need to write the correct formula for my products. Be sure to balance and cancel out. This is a big one. Those charges, because we're talking about ionic compounds, right? Ionic compounds come with charges. We need to rewrite our equation. Reactants on the left of the arrow, products on the right. Then we have to balance it. Let's walk through one together so we know what I'm talking about. We may have time to get through two of them. So on my table, I know that when I added copper sulfate, barium nitrate, I saw a precipitate. It was like a whitish powder. I know when I combined copper sulfate and potassium iodide, I got no precipitate. I got a change in color, but I didn't see any solid material floating in my liquid, right? So these are my reactants. My copper sulfate and my barium nitrate are my two reactants. So I can write that down here. CuSO4 plus BaNO3, 2, is going to yield two things I don't know. What I need to do is, one, predict the products. Number 2, write equation. Number 3, balance equation. These are the 3 things I'm going to do for my 10 precipitate combinations. There were more than 10 on your table. The one that I do with you, the 1 or 2 that I do with you, can count towards your 10. I have no problem with that. So, let's talk about how do I get this one. I'm going to split my cation and my anion apart from each other. My copper is going to be my A. My sulfate is going to be my B. So my cation's A. My anion's B. My cation C. My anion is D. What's the first combination I can make? What two things are going to combine to create a new molecule? Copper and the nitrate, right? All right. So I got Cu and SO4. Oh, not SO4. I'm going to slide this down. I got Cu and NO3. What is my charge on my nitrate? Is it a -1, a -2, a -3, or a -4? What is the charge on my polyatomic ion? A -1. Take a quick second. Hello. Yo. Katya for early dismissal. She's on her way right now. Bye now. Katya, grab your stuff. You got early dismissal, girl. Now, copper is in that weird transition metal stuff. And I know that they like to exist in either as a +2 or a +3. How do I know which version of copper am I working with? What's the charge on my sulfate? -1, -2, -3, or -4? Not -3. -2. I have 1 copper. Which version of copper cancels out the -2? Is it the +2 or the +3? +2. So I'm working with copper 2 nitrate. Now my question to you. Does my +2 and -1 cancel each other out? No. I'm going to need to get more of something. I'm either going to need more copper or more nitrate. Which one am I going to pick up to cancel out the charges? I need at least 1 more nitrate, right? So, my first combination is copper 2 nitrate. That's my AD. So what's my BC? Barium sulfate. Very nice. So barium and the sulfate. Now the nice thing about the sulfate, we already know what charge it is, right? We know it's a -2. What's the cation charge of the barium? You can look at your periodic table and figure that out. Everyone should have one in front of them. It's a +2, right? Barium is the second to last alkaline earth metal, right? Plus 2. Do my charges cancel each other out? Absolutely. So, BaSO4. I have predicted my products. Now, I'm going to rewrite my equation. And I'm going to leave some space for coefficients if I need them. Copper sulfate plus barium nitrate. Arrow points over to barium sulfate plus copper nitrate. So here is my equation. So I've rewritten my equation. That's number 2. Number 1, I predicted my answers, my products. Number 2, I've written out my equation. Number 3, I have to make sure I've balanced my equation. Now, I'm in a very interesting spot. I could, in theory, treat each atom as its separate thing and count up to 5 different atoms. Copper, sulfur, oxygen, barium, and nitrogen. But I am a big brain individual that goes to Mr. Wiseman's class on a regular basis. And Mr. Wiseman tells us, hey, you don't have to count the polyatomic ions, their elements separate of each other, if they're in my reactant and in my product. Is my sulfate in my reactant and product? Is the sulfate in the reactant and in the product? Then why would I count them separately? I can count that as one unit. My nitrate, is it in my reactant and my product? Why would I count them separately? I can count them as one thing. So instead of counting 5 different atoms across several different sources, like with oxygens, I have 2 different sources for oxygens. That can get kind of crazy. What I can do is count my copper atoms, count my sulfate ions, my barium atoms, and my nitrate ions. So under the arrow, you're going to write out your 4 or 5, however many atoms you're dealing with. And usually it should be 4. You're going to make sure that I have the same number of copper on both sides, the same number of sulfate on both sides, the same number of barium on both sides, and the same number of nitrates on both sides. Now, I always say that you should always look for the one that's different in your reactants and your product. Let's go down our list, right? I see 1 copper over here. I see 1 copper over here. Copper's probably not a good choice. I got 1 sulfate over here. I got 1 sulfate over here. That's not a good choice either. I got 1 barium over here. I got 1 barium over here. Uh-oh. I'm starting to see a pattern. 2 nitrates over here. 2 nitrates over here. Is my equation balanced? Same number of atoms in my reactants are found in the products. Therefore, I'm done. The skeleton of my equation is my balanced equation. Is that going to happen every time? No. In fact, let's take a look at one where that's not the case. That'll be our last one that we do, referring to the homework. Now, I know when I added lead nitrate and calcium iodide to each other, I formed a bright yellow powder in my well. Yes? Everyone recorded that was bright yellow, and we definitely recorded that it produced a precipitate. We're feeling good about that answer, yes? All right. So I have my two reactants then. I have lead, nitrate, and I have calcium iodide. And I need to figure out what they form. If I follow my double replacement skeleton equation, AB plus CD equals BC plus AD, what is A on my reactant side? Is it the lead, the nitrate, the calcium, or the iodine? What's A here? If my AB plus CD produces BC plus AD, what is A in my reactant side? Lead. What's B? Nitrate. What's C? Potassium. What's D? Iodide. So, what can I predict as my first product? I can do lead and iodine, right? All right. Now, the nice thing about iodine is it only has one possible anion that we can work with, right? What is the anion for iodine? -1, -2, -3, or -4? -1. It's one of my last halogens. Now, lead, I know, comes in two types of flavors. It likes to come in either +2 or likes to come in +4. To figure out which version of lead I'm working with, I gotta go back to my reactant to see what it is. We said that nitrate had a -1 or a -2 charge. Which one does nitrate have? A -1 charge. There are two of them. So that means I have a -2 charge on the anion. What must my lead be to cancel out that charge? A +2 or +4? +2. Is my +2 and my -1, do they cancel each other out? No. What do I need more of? I need another iodine. So my first combination, my first answers is lead to iodide. What is the other combination I'm working with? My other product? Potassium and nitrate. Now I know nitrate has a -1 charge. We feel comfortable putting a -1 charge on nitrate. If you don't, I need you to start. What is the cation charge for potassium? +1. It's number 3 in my alkali metals in group 1. Do my charges cancel each other out? Perfect. KNO3. Those are my products. Now, because I did a lot of writing, I want to clean it up. So I'm going to slide my paper down a little bit. PbNO3 2 plus Ki will yield potassium nitrate plus lead iodide. Now, like before, so this is number 2. Second thing I have to do, number 3, I got to balance out my atoms. Pb. Can I treat nitrate as one thing? Absolutely. I see nitrate over here, my reactant side. I see it over here on my product side. Therefore, I could treat it as one thing. NO3. Potassium and iodine. Now, like I said, when you're balancing your equation, always start with a thing that does not match either side. I got one lead, I got one lead. Probably not the best place to start then. I got 2 nitrates, I got 1 nitrates. I got one possible spot. Let's see if there's any better ones. 1 potassium, 1 potassium. All right, not going to work. 1 iodine, 2 iodine. So, the best place for me to attack this question is either starting with the nitrate or the iodine. Which one do we want to start off with? Sure. I have 2 nitrates on one side. I have 1 nitrate on the other side. How am I going to fix this? Yeah, multiply my potassium nitrate by 2, right? So now I have 2. Now I have 2 times 1 nitrate gives me 2 nitrates. Now, because I changed the nitrate, I've also changed my count of potassium. My product side has 2 potassiums. How many do I have on my reactant side? I only have 1. How do I fix that? Multiply that by 2. 2 times 1 potassium now gives me 2 potassium. All right, so since I changed potassium here, I also changed the iodine too, right? So that's my next place, second best to go. 2 iodines. How many iodines do I have on my opposite side? 2. Are they balanced? All right, so I only got one last thing to do. I have 1 lead on my reactant. How many leads do I have on my product side? 1. 3 steps. Predict your product, write the equation, balance the equation. It's really good right now that when you're doing step 1, is that you break it up into your A, B's, and your C, D's, and then figure out what your products are. The nice thing about double replacement reaction is that it follows this pattern every time. Because remember, A and C cannot interact with each other because they share the same charge. They're positively charged. They'll repel from one another. B and D share the same negative charge. They're going to repel from each other. So what I'm saying in the second one is that for this reaction to occur, I need 1 molecule of lead 2 nitrate and 2 molecules of potassium iodide. When they react with each other, they will form 2 molecules of potassium nitrate and 1 molecule of lead 2 iodide. Now, the nice thing about this is that these numbers are they're important for balancing the equation. But remember, we have tons of atoms floating around the same place. The molar mass of any compound or element, in case we run into them, is equal to 6.022 times 10 to the 23 molecules. Finding 2 calcium iodide to interact with 1 molecule of lead 2 nitrate is easy. Don't get hung up on the numbers that you're going to form because you're dealing with an unimaginable large number. Keep that in mind as you go about with your equations. So your homework, give me 1 second, Christina. Your homework is to choose 8 other reactions from this table. I give you the reactants. You must predict the product. You must write out the equation, and then you must balance said equation. That's all you have to do for homework. The hard part is already done for you. If you do not have this table filled out, I'm going to give you a minute to look at your partner on your left and the partner to your right and get somebody's data and record that information. Number 1. Number 2, once that material has been recorded, I want you to clear off your desk because that was my alarm for the quiz. Christina, you had your hand up. My pass is right there. Yes, you may. Does anyone have any questions on the homework? That's fine. Any question on the homework, guys? Going once, going twice. If you are done recording your data, put your papers away off your table. Let's go ahead and get ready to take this test.